Okay, good morning guys. I know it's probably not morning for you, but it is for me. So, we are going to finish up this page. And actually I think it's going to be a little bit easier. It's going to make a little bit more sense than the other page. Okay, so if you look at these two problems, you don't have to worry about like the complexity of that first one we did where you had the fraction and then you had the parentheses and all of that. Okay, if you look here, you just have an x squared. There's no x. It's not a trinomial, okay? So when you just have an x squared, this is what makes it so easy to just kind of solve. When you just have an x squared, you can isolate that, okay? And then at the very end, you can square root it because that's the opposite of that squaring, okay? So since this is the only variable I have in this whole problem, okay, I don't want to make it a trinomial, or I don't treat it like a trinomial because it's not. I just isolate that. So I actually move everything away just like we would solve back in Algebra 1. I just get everything off to the other side. So add 16, I get 2x squared and 50, okay? And then I want the x squared by itself, so I divide both sides by 2. And I get x squared is 25, okay? And then now I can isolate the x even more and just get an x by square rooting that squared out, okay? And if I do it to the left, I do it to the right. And on the other page, I mentioned that whenever you square root, okay, you get the positive version and the negative version, okay? Because there should be two answers. We know that. That squared means there should be two answers. And so the solution is positive or negative 5, okay? But you only have to worry about positive and negative when you're solving. If I just ask you, well, what's the square root of 49? Well, that's a 7, okay? But if I'm solving this x value, if I put it in here, I could either square a 5 and get 25 in there, or I could square a negative 5. Because a negative times a negative will also give me a 25, okay? So that's a little bit easier. It's the only x in the problem, so you isolate it, just like we would back in Algebra 1, okay? Then the next problem actually refers to example 4 on the other page, where instead of a height of 59, now we just do a height of 27, okay? So let me scroll that. Okay. Alright, so it says to go back to example 4. Suppose that the water balloon, oh my goodness, it's early in the morning. Balloon is dropped from a height of 27 feet. How long does it take for the balloon to hit the sidewalk? So again, the formula is H equals, what was it, negative 16t squared, because that's time, plus h sub 0, okay? So h sub 0 is where we start, and h is where we're wanting it to hit, okay? 0 usually means like the beginning, where you start something, okay? And then this is like where we want it to hit. And in our case, again, we want it to hit the ground, so the height would be at 0. But we're starting, it says, up at 27 feet instead. So, let me put that down. This is where we hit the ground. So that's 0. Okay, and this is our starting height. Okay, so we hit the ground at 0. In this case, we are starting at 27 feet. Okay, and then this one is a lot like the other one, t squared, that's the only variable, so you want to isolate it, okay? You can't make a trinomial out of this, so you just go ahead and just isolate the t squared and square root at the end. So the first thing we do is subtract our 27. The next thing we do is divide by negative 16. And that gives us a fraction, okay? And I wrote it like this on purpose because The opposite of squaring is square rooting. So those cancel. But remember, we can split that up, and this one will square root, and that one will at least simplify. So let me go off to the side over here. We've got the square root of 27 over the square root of 16. That is what t is. But we could simplify it, which is what we've been practicing. If I go off to the side, the factor pair of 27 that I want to use is 9 and 3, because 9 will square root. Okay? So this changes to, I'm trying to think of where I want to write it. I'll put it on this side. 3 root 3, because I square root the 9, and then root 3 is still there. And I can square root that to a 4. Now in Algebra 2, that's the type of thing that we usually write just because it looks mathematical and everything's reduced and everything. But this was a real question, so we really want to answer the question. And the question was, how long does it take? Well, if you were to put that into your calculator, you get a decimal and it takes about 1.3 seconds. Okay, so to actually answer the question, okay, it's about 1.3 seconds, which is the same as that fraction. So like on a test or a quiz, usually you just solve it and then you just keep it in some sort of fraction or radical form. But since this was a word problem, since this was actually trying to figure out a time, we converted it to something that we understood. And we understand just over 1 second, a little under 1.5, okay? But you are going to see like both on your SOL. You're going to see some real questions where you're going to have to put real answers, meaning like reality, like actual, okay? Or you're going to have just, arbitrary problems where you just have to solve and show that you know how to do this in Algebra 2 and that kinds of stuff, okay? All right, so I think we have a couple more problems. Again, it's just going to be solving solving for a variable, but it's going to bring in a little bit of imaginary stuff that we've already talked about. So let's scroll. All right, so, so we go through and we just solve this like normal. Again, x squared is the only variable in this problem, so it's isolated, okay? And at the very end, we'll square root in order to get it all the way down to just x. So subtract 15 from both sides, and you get 2x squared equals negative 50. Okay, this looks a lot like the other problem that we did. Then we divide both sides by 2, so we get x squared equals negative 25. Okay, then we take the square root, because that's the opposite of squaring. So square root, square root. But when we take the square root, remember, since I square rooted both sides, I do get a positive or a negative, because again, we're solving, so it could be a positive or a negative. And then we actually want to work out that root 25. It says, write it in terms of I, so this negative, okay, means that it's I, because that's what we talked about last class. So plus or minus I square root of 25. But also, the square root of 25 we know is the number 5, so we can actually clean this whole thing up by saying plus or minus 5, because that's the square root of that, and then I, because that's where the negative came from. Now this took it in a little bit more steps than I think we need to. It broke it down one piece at a time, plus or minus, then I, then square root our 25. We can actually just do that all at the same time. If you see the perfect square, pull it out. If you see the I, go ahead and pull it out, and then always make it plus or minus, okay? So the solutions are positive 5i, and negative 5i, okay? So the other problem is going to look a lot like that. And then that's all it is. Let me get a different color. Okay, wish I could scroll it a little bit more, but I can't, because it's at the bottom of your page, so. Okay, so again, x squared is the only variable, so we want to isolate it. It's the only one, so we get it all by itself. So let's first subtract 13 over, and we get negative 36, I think. So, oh, this isn't the marker I wanted. I want to make sure you can see it, so that's why I'm changing markers. Okay, so I subtract 13, and I get 3x squared equals negative 36. Okay? Then I divide by 3, and I get x squared equals negative 12. Okay? Then the opposite of squaring is square rooting. So I'm going to square root both sides. So I have x by itself. Remember, whenever you square root both sides, you should get two versions, positive and negative. There's also two answers because it's squared, okay? So I hope that remind you I need a positive and a negative version. So positive and negative. It's a negative, it's the square root of a negative 12, so we can pull that I out. And then let's deal with that 12, okay? That 12 will simplify. It doesn't square root all the time. Again, remember that's I. Okay, that 12 doesn't square root completely, but we can simplify it. So off to the side, the factor pair that we care about is 4 times 3, because 4 will square root. So let me break it down just a little bit so that you follow me. So it's the square root of 4 and the square root of 3, and then we know that the square root of 4 is just the number 2. So we're going to go ahead and we're going to square root that. And then we always put it in front of the I. So plus or minus 2i, and then square root of 3 is still there. So this became that. Okay? So that you can kind of see where that came from. So this is our answer. And we're going to talk about what that looks like when it comes to solutions and stuff like that down the road. Okay, but that is actually how it works out. There's two answers, one's positive, one's negative. It's imaginary because there was a negative in the root, and then we just simplified the root like we've been practicing, okay? I think that's it. So we'll practice more in class, okay guys?